This video deals with one of the most interesting features about Einstein's theory of general relativity, the distortion of light produced by the geometry of space-time, which is known as gravitational lensing. Let's go step by step. First, let's make a quick review of general relativity. In simple words, the most fundamental statement of this theory is that space and time are not treated separately. Instead, they are closely linked with each other, and together they form the four-dimensional space in which all the events in the universe occur, the so-called space-time. Starting from the fact that the speed of light is constant, Albert Einstein showed that concepts such as speed and the duration of events depend on the geometry of that space-time, and that geometry is affected by the presence of massive objects. This changed the understanding of gravity. In a few words, gravity is not a force. It is the effect caused by the distortion of space-time in the vicinity of massive objects. What we experience as gravity is nothing but the tendency to follow this geometry. On Earth, this geometry points towards the center of Earth, so we tend to move in this direction, and we feel a mysterious force that is dragging us down. This effect does not only affect objects with mass, such as humans or mountains, it also affects light. And this is when we can really move into the topic of the video. It turns out that when a light beam passes next to an object with mass that changes the geometry of space-time, it will naturally follow this geometry, and so it will not travel in a straight line necessarily. The overall effect of this consequence of general relativity is that objects with mass are able to distort the images of background objects, because their light is a victim of the strange path that space-time makes it follow. Obviously, you need objects that have a lot of mass in order to see this effect, and this is why we can only evidence these effects with astrophysical objects, such as stars, galaxies, and galaxy clusters. Although, in principle, you can see this effect with smaller objects that have small masses. The name gravitational lensing comes from the fact that the distortion of images happens in a very similar way as it happens with a simple optical lens on Earth. You know, some objects can seem to be bigger, or they seem to be closer, or you can see multiple images depending on the type of lens that you use. In astronomy, we usually talk about two different types of gravitational lensing. One is weak lensing, which basically distorts the shapes of images and aligns those images around the object with mass. And the other type of gravitational lensing is my favorite, is strong lensing, which effectively stretches out the images. And in very rare occasions you can get a ring of light, which is called Einstein ring. Gravitational lensing is very useful in our research because it allows us to map dark matter regions, large-scale structure, locate and observe very faint objects, study mass content, and so on. In conclusion, massive objects act as lenses of the cosmos, and just like glass lenses, they can be used to show us many things that we can't see with our instruments and current telescopes, and they can provide much more insight into the wonders of the universe. Thanks for watching, and don't forget to subscribe for more cool astronomy.